Welcome to Lecture 8 of our GMP and Quality Fundamentals series. Today we're discussing data integrity and the ALCOA Plus principles. This lecture covers the foundation of everything we do in quality. Let's start with the basics. What is data integrity? Data integrity means your data is complete, consistent, accurate, and trustworthy. It means your data accurately reflects what actually happened. It can be trusted for decisions. It remains unchanged unless properly documented. It's available when needed. And it can be traced to its source. Why does it matter? Patient safety depends on accurate data. Regulatory decisions are based on your data. Product quality is verified by data. Investigations rely on reliable records. Without data integrity, all your GMP systems, CAPA, change control, deviations are meaningless. Let me put this in perspective from the FDA's viewpoint. The FDA says, if it's not documented, it didn't happen. And if it's not documented correctly, it might as well not have happened. What are the real consequences of data integrity failures? Warning letters and import alerts. Product recalls and seizures. Consent decrees, which means third-party oversight. Criminal prosecution for falsified data. And loss of trust and reputation. Here's a recent FDA trend. Data integrity violations are the #1 citation in inspections. Not because labs can't test properly, but because documentation and record-keeping fail. Good science plus bad documentation equals FDA findings. Now let's look at the ALCOA principles. ALCOA was introduced by the FDA in the 1990s. It stands for 5 core principles for data integrity. A equals attributable, L equals legible, C equals contemporaneous, O equals original, A equals accurate. Later, this evolved to ALCOA Plus, which added complete, consistent, enduring, and available. Today we'll cover all 9 principles. Each one is critical. Each one is commonly violated. And each one can trigger FDA findings. Let's start with the first A, attributable. Every action must be traced to a person. Who did what, and when? Requirements, full name or unique identifier. Date and time. Cannot be anonymous. Cannot use shared logins. Good practice. Analyzed by M. Abdullahpour, March 15, 2024, 1430. Bad practice. Analyzed by Lab Tech. Which one? Using supervisor's login. Not attributable to you. QC department. Who specifically? Why it matters. During investigations, you need to know who to interview. L equals legible. Data must be readable and understandable. Not just now, but years from now. Requirements: clear handwriting if using paper. Permanent ink, no pencil. No erasable pen. Electronic data must be accessible. Good practice: print clearly if handwriting. Use black or blue permanent ink. Electronic records with proper formatting. Bad practice: sloppy handwriting. Can't read it equals can't use it. Pencil entries, which can be erased. Faded thermal paper that disappears over time. Why it matters: if an FDA auditor can't read it, you failed data integrity. C equals contemporaneous. Record data at the time of activity. Not later, not from memory. Requirements: real-time documentation. Same day as activity. No backdating. Timestamps should match the sequence of work. Good practice: record pH reading immediately, pH 7.2 at 10:15. Log sample receipt when it arrives. Bad practice: writing all results at end of day from memory. Batch record completed days after production. I'll fill it in tomorrow. Filling in blank forms with yesterday's date. Why it matters: memory is unreliable. Contemporaneous records are trustworthy. O equals original. Keep the original record, or a certified true copy. Requirements: original data preserved. For electronic data, raw data files retained. For paper, original document kept. Copies clearly marked as copy. Good practice: HPLC raw data files archived. Original batch record in QA archive. Certified true copies for distribution. Bad practice: only keeping summary report while raw data is deleted. Rewriting batch records neatly. Printing only final chromatogram, not the full run. Transcribing handwritten data to a clean sheet. Why it matters. Investigations need original data. Copies can hide problems. The second A equals accurate. Data must correctly reflect what happened. No errors. No manipulation. Requirements. True representation of observation. No rounding unless justified. No selective reporting. Errors corrected properly with single line, initials, and date. Good practice. Record what you see. pH 6.8, even if spec is 7.0 plus or minus 0.5. Correct errors by crossing out, initialing, dating, and writing the correct value. Bad practice. Rounding 6.8 to 7.0 to meet spec. Rerunning only failed tests until they pass. Recording expected value instead of actual. Using correction fluid or whiteout. Why it matters. Inaccurate data leads to wrong decisions, which leads to patient risk. Now let's look at the ALCOA Plus extensions. C equals complete. All required information must be included. Nothing missing. Requirements. Full dataset, not cherry-picked. All tests documented, not just passing ones. Context provided, like conditions and equipment. Supporting information attached. Good practice. Report all 3 HPLC runs, including the failed one. Sample temperature 25 degrees Celsius, humidity 45% RH. Attach calibration records with test results. Bad practice. Only reporting the passing result. Missing sample ID or lot number. No units on measurements. Is it mg or g? Blank fields in batch records. Why it matters. Incomplete data can't be evaluated properly. C equals consistent. Data is internally coherent. No contradictions. Requirements. Timestamps follow logical sequence. Data matches across systems. Audit trails align with records. Cross-references are correct. Good practice. Sample logged at 9 o'clock, tested at 10 o'clock. That's logical. LIMS result matches paper record. Balance printout date equals batch record date. Bad practice. Sample tested at 10 o'clock, logged at 11 o'clock. That's backwards. LIMS says 98.5%, batch record says 98.2%. Autoclave completed 1300 hours, but signed off at 12 o'clock. We can timestamp on equipment in a closed facility. Why it matters. Inconsistencies suggest data manipulation. E equals enduring. Data must last for its required retention period. Usually product shelf life plus 1 year, minimum 3 years. Requirements. Permanent recording media. Protected from deterioration. Backed up if electronic. Migration plan for obsolete systems. Good practice. Permanent income quality paper. Electronic records backed up regularly. Plan to migrate data before system retirement. Bad practice. Thermal paper that fades in months. Pencil or erasable ink. Only one copy of electronic data with no backup. Data on obsolete system that can't be accessed. Why it matters. Must be able to review records during the product's shelf life. A equals available. Data must be accessible when needed. For review, inspection, or investigation. Requirements. Organized and retrievable. Secure but accessible. Electronic data readable, not encrypted without a key. Archive system with index. Good practice. Clear filing system with index. Electronic data with search function. Can retrieve records within 24 hours. Audit trail accessible. Bad practice. I know it's here somewhere, but can't find it. Files in random boxes in storage. Electronic data on personal laptop only. Encrypted data with password lost. Why it matters. Unavailable data equals non-existent data in the FDA's eyes. Now let's look at common data integrity failures. What goes wrong? Top violation number 1. Shared login credentials. Multiple people using same username and password. This violates Attributable. Number 2. Testing into compliance. Rerunning tests until passing, not reporting failures. Violates complete and accurate. Number 3. Backdating records. Filling in forms with past dates. Violates Contemporaneous. Number 4. deleting failed results. Only keeping passing data. Violates complete and original. Number 5. No audit trail. Can't track who changed what and when. Violates attributable and available. More violations. Number 6. Pre-signed blank forms. Supervisor signs before work is done. Violates contemporaneous and attributable. Number 7. Data not backed up. Electronic records with no backup. Violates enduring and available. Number 8. Poor error corrections. Using whiteout, erasing, overwriting. Violates original and accurate. Number 9. Uncontrolled spreadsheets. Excel files with no version control or audit trail. Violates attributable, complete, and consistent. Number 10. Missing raw data. Only summary reports while raw data is deleted. Violates original and complete. Let's discuss electronic records in 21 CFR Part 11. 21 CFR Part 11 is the FDA regulation for electronic records and signatures. It applies when you use electronic systems for GMP records, or when you use electronic signatures instead of handwritten signatures. Key requirements include system validation, prove the system works reliably, audit trail, track who did what and when. Cannot be disabled. Regular review required. Access control, unique user IDs with no sharing. Secure passwords. Automatic logout after inactivity. Electronic signatures, legally binding as handwritten. Two-factor authentication using username plus password. For electronic records best practices, system design should include built-in audit trail that can't be turned off. Data integrity checks using checksums. Automatic timestamps. Version control. User management. Individual user accounts never shared. Role-based access so you only see what you need. Disable accounts when people leave. Password complexity requirements. Data protection. Regular backups. Daily minimum. Backup testing to ensure you can restore. Disaster recovery plan. Migration plan for system upgrades. Documentation. Standard operating procedures for system use. Training records for all users. Validation documentation. Now let's discuss maintaining data integrity with practical steps. Culture. Create a no-blame environment for reporting errors. Management sets the example. Focus on quality over speed. Training. ALCOA principles for all staff. Proper documentation techniques. How to correct errors properly. Regular refresher training. Procedures. Clear SOPs for data recording. Defined review and approval processes. Error correction procedures. Data retention and archive procedures. Technology. Part 11 compliance systems. Validated software. Regular system backups. Audit trail review. How do you correct errors properly? For paper records, never erase or use correction fluid. Never scribble out so the original is unreadable. Never write over the error. Never tear out the page. Always use a single line through the error so the original is still visible. Write the correct value next to it. Initial and date the correction. Add reason for change if not obvious. Example, pH 7.8 crossed out, 7.2 written next to it, and May March 15, 24, with note, transcription error. For electronic records, the system should track all changes. Audit trail shows original plus correction. Reason for change documented. User and timestamp automatic. Data review and quality oversight are critical. Regular data review. A second person reviews all critical data. Check for completeness and accuracy. Verify calculations. Compare trends over time. Audit trail review. Review electronic audit trails regularly. Look for unusual patterns. Weekend or night entries when no one was working. Deleted or modified data. Failed login attempts. Quality oversight. QA reviews batch records. Periodic data integrity audits. Trending and metrics. Management review of systems. Investigations. Any data integrity issue triggers investigation. Root cause analysis. CAPA to prevent recurrence. Track key data integrity indicators. Error rate. Number of corrections per 100 records. Trend over time. By department or person to identify training needs. Audit trail findings. Failed login attempts. After hours entries. Deleted records. Modified data. System issues. Backup failures. System downtime. Lost data incidents. Training compliance. Percentage of staff trained on data integrity. Refresher training completion. Review completion. Percentage of records reviewed on time. Backlog of pending reviews. Here's a key concept to remember. If it's not documented, it didn't happen. Document it right the first time. Let me share a real case study of data integrity failure. Company, a major pharmaceutical manufacturer. The problem: lab analysts shared login credentials. Failed tests were deleted from LMS. Only passing results were reported. Batch records were backdated. No audit trail review occurred. Discovery: an FDA inspector requested raw HPLC data. They found deleted files in the computer's recycle bin. The audit log showed multiple deletions. They couldn't attribute results to any specific analyst. Consequences: warning letter. All products placed on import alert. Consent decree requiring third-party oversight. $500 million in lost sales. Criminal charges for the lab manager. 5+ years to recover their reputation. What are the lessons from this case study? Small violations accumulate. It started with just sharing passwords. This led to deleting failures. It ended with systematic fraud. Culture matters. There was pressure to pass tests quickly. No questions were asked when tests kept failing. Management turned a blind eye. Systems prevent problems. Audit trails would have caught the deletions. Individual logins would show who did what. Regular oversight would have stopped it early. The lesson: data integrity isn't optional. It's not bureaucracy. It's protecting patients and your company. Let's look at our cake example for data integrity. Scenario: recording cake mixing time the wrong way, which violates multiple principles. Operator uses supervisor's login. Not attributable. Records mixing time from memory at end of shift. Not contemporaneous. Changes 25 minutes to 20 minutes to meet spec. Not accurate. Uses correction fluid to hide original. Not original. No documentation of why it was changed. Not complete. The right way, which follows ALCOA Plus. Operator logs in with own credentials. Attributable. Record start time when mixer starts, 10:15. Contemporaneous. Records actual stop time, 10:40, which is 25 minutes total. Accurate. Notes deviation. Mixing time 25 minutes, spec 20 plus or minus 2 minutes. Complete. Initiates deviation investigation. Original record preserved. Batch record stored in QA archive. Enduring. Result: problem identified and fixed. The mixing blade was worn. Let's summarize the key takeaways. Data integrity is the foundation of GMP. ALCOA principles are attributable, legible, contemporaneous, original, accurate. ALCOA Plus adds complete, consistent, enduring, available. Every principle matters. Violating one undermines trust. 21 CFR Part 11 governs electronic records. Audit trails must be enabled and reviewed. Never share login credentials. Record data at time of activity. Be contemporaneous. Correct errors properly using single line, initials, and date. Keep original records, not just summaries. Data integrity failures have serious consequences. Culture, training, and systems all contribute. If it's not documented right, it didn't happen right. In our next lecture, Lecture 9, we'll discuss audits and inspections, internal, external, and regulatory. Thank you for joining me for Lecture 8. If you found this helpful, please like, subscribe, and check out the PDF download link in the description. See you in Lecture 9.